Hello everybody, welcome to another video lesson. We are continuing graphing trigonometric functions. However, today we are looking at reciprocal functions. We're going to look at secant, cosecant, and cotangent. So let's take a look at how we do this. All right, our key for success, we are going to graph the main trig function, meaning if I am graphing secant, first thing I want to do is graph cosine. Okay, so I know sine, cosine, tangent, those are kind of our quote unquote main trig functions, right? So that's what I mean when I say main trig function. And we're going to do that first, and then we're going to draw vertical asymptotes where our main function crosses our midline or our x-axis. Okay, and then we can go ahead and graph our reciprocal function. So let's take a look at this example here of secant. So I have y equals secant theta, that's here in blue. And what I have here for a reference is going to be y equals cosine theta. And notice here, where we are crossing our midline, we have these vertical asymptotes. Now, why do we have these vertical asymptotes? Well, let's think about what a reciprocal function is. Secant theta is equal to 1 over cosine theta. That's why it's called a reciprocal function, right? So when cosine is equal to 0, wouldn't we have 1 over 0? We would, right? So then secant theta would be undefined at that point, which is why we have these vertical asymptotes here where cosine theta is crossing the x-axis, because that cosine theta is equal to 0 at that point. And then why do we have this? Why is the reciprocal going off in the other direction, going off into infinity on each of its periods? Well, let's think. If I have a really, really small number, okay, and I have 1 divided by that really small number, what does that give me? Well, that gives me a really, really big number, right? So if I'm looking here at this middle period, as cosine theta gets really, 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 really close to 0, not touching 0, but really, really close to 0, then the reciprocal of that would be getting really, 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 really big, right? Infinitely big. So that is why as my cosine graph approaches 0, my secant graph gets larger and larger and larger, off into infinity actually. And then once cosine actually hits 0, we have that vertical asymptote. And then similarly, as cosine gets smaller, our secant theta gets larger. That's what we just said. Okay, so that is why we have these graphs going off into infinity in each period. Okay, so let's go ahead and graph now cosecant. Let's find the period of and graph y is equal to cosecant 2 theta. So since cosecant is based off of sine, right? It's the reciprocal function for sine. Then our period is actually going to be the same as sine 2 theta. So the period of sine 2 theta would be 2 pi over absolute value of b, which is going to be 2 pi over 2, or just pi. So our first step is going to be graphing sine of 2 theta. Now I know my amplitude is 1, my period is pi. So let's go ahead and graph that out. That will look something like this. We did this in a previous video. Now, second thing, we're going to place our vertical asymptotes at our x-intercepts. So wherever I have an x-intercept here, I'm going to place a vertical asymptote. And then we can start at the peaks and graph our reciprocals going off into the other direction. So just looking at this period right here, we're going to start right here. This is actually going to share this point right here at the peak. Okay, this point does get shared. And then again, as my sine value approaches 0, right, my cosecant value is getting larger and larger and larger. And here, this is a negative value, so we're going off into negative infinity here on this period. Okay. Now, once you have this graph, we are just repeating this in each one of my periods. Okay. So our final graph would be here in black. Okay. So the part in black, as well as the vertical asymptotes, is what really is required for graphing our cosecant and all of our reciprocal functions. All right. Now, when you guys graph sine, cosine, and tangent for your reference, whenever it's a reference graph, you need to make sure that this is a dotted line. Okay. I need to know that you know the difference between this sinusoid and what we have here, our reciprocal function. Okay, so make sure your reference graphs are dotted and then you have a solid line for your final graphs. Okay. All right, you guys go ahead now, using degrees for this one, use degrees, find the period of and graph y is equal to 2 secant 3 theta. 2 secant 3 theta. Pause the video, see if you can't figure that out. And use this scale here when you create your graph. Okay, we have this is degrees, my x-axis, or my theta, my horizontal axis. This is degrees, and then my y-axis here. Okay, hopefully you got a graph that looks something like this. I graphed a full 7 periods here. Make sure you're graphing at least 3 for these. Okay, 3 or even 4 would be better. But this is what our graph would look like. Okay, we have an amplitude of 2 for our 2 cosine 3 theta. So we are starting at 2 and going up in the reciprocal direction. All right, now let's go ahead and graph our cotangent. So we're going to find the period of and graph y is equal to -3 cotangent to theta. So I've got, first thing we're going to graph y is equal to -3 tangent to theta. So keep in mind, we don't have an amplitude for tangent or cotangent, right? But we do have a period value, and that's going to be pi over b. So that's going to be pi over 2. So let's go ahead and graph this out. We'll pick some values, graph that. So this is what tangent would look like, or my tangent graph. So now we're going to place vertical asymptotes where x is, or we're crossing our x-intercept, just like that. And then we can graph our reciprocal function, keeping in mind our midline intercepts are where we're going to have vertical asymptotes for our tangent. Okay, so now wherever we had vertical asymptotes, that's actually where we're going to have these new midline intercepts. So for my tangent, we had vertical asymptotes at pi over 4 values, right? So that is where we are going to place our midline intercepts now, okay? So then you can go ahead and graph your reciprocal. So here, as my tangent graph gets closer and closer to 0, right? That is where my cotangent graph is going off into infinity, right? In both directions. As tangent gets closer and closer to 0, my cotangent is going off into infinity. And as tangent gets larger and larger, my cotangent is getting smaller and smaller, closer to 0, right? So then once you have one of those curves, you can go ahead and copy that into each period, and you are done. So that is it for this video, guys. Good luck with your practice.